and we could be advertising this over to other BGP peers. So this is one solution. Let's remove this static route of router 2. To do so, I'm gonna just go up and remove this static route, and to verify this I'm gonna show the IP routing table, and immediately we will find out that the static route has gone. And we're gonna also verify the BGP database, and again we will find out that this BGP database entry has gone as well. And let's verify this on router 1. Again, the entry has been removed from router 1 database. We have no prefixes or information about 172.16 network. So this is actually how to use the network command. There is AutoSummarization, okay, in BGP, but it's not enabled by default, unlike EIGRP. EIGRP has AutoSummarization, but it is enabled by default. In BGP, AutoSummarization is off by default. So AutoSummarization makes BGP summarize networks whenever it has subnets of major networks. Just like if we have on router 2 right here this 172.16.20 network. Excuse me. Whenever we have a subnet just like the 172.16.20/24, router 2 will advertise a summary, okay, to the default boundary. Namely, it will advertise only 172.16.00/16 to other routers. It will make auto-summarization, and it's off by default. It could be enabled using the auto-summary command at the routing process level. So, and this also affects the behavior of the network command. So on router 2, to enable auto-summarization, you just use the auto-summary at the routing process level or submode. Router BGP2, then auto-summary, and you hit enter. This way, if you are to use the network 172.16.00 and you just hit enter, router 2, because of the auto-summary effect, will advertise any subnet of the 172.16 network. And to verify this, we're gonna use show IP BGP command, and yes indeed we can see that router 2 has installed the 172.16.00 network in its BGP database, and it will advertise this over to other routers just like router 2. And if we are to verify this, we're gonna show IP BGP, and indeed we can see that 172.16.00/16 is being learned, okay, at router 1 from both router 2 and 3. And again, router 1 prefers the eBGP learned route, the route that is being learned from the eBGP neighbor. So this is the effect of auto-summary on our behavior or our network command behavior. Other way to inject routes into BGP is by doing redistribution. Okay, and to do so, let's do this. Let's get back to our design, and okay, let's make router 1 redistribute all connected interfaces into BGP. And if you are not that familiar with redistribution, redistribution is simply about taking some prefixes from one domain and redistribute them into another domain. For example, if you have rep domain and BGP domain, so you could have networks learned by rep being sent over and translated into BGP through a router that is working just like a translator. Okay, so we have a router that is translating between two different languages. So we're gonna take connected networks, okay, or even static routes, whatever, and we will be redistributing them into BGP. To do so, I'm gonna go over to router 1 and at the routing process, router BGP 13, I'm gonna tell the router to redistribute connected and hit enter. This way, router 1 should take all connected networks and put them inside the BGP database, and indeed, yes, it has done so. Now it is injecting the 172.16.10/24, this network right here, and of course this network and other connected networks as well. We have like 5-6 of them, all networks that have quad 0 as next hop, meaning that they are locally originated or injected by the local router into BGP database. And of course all of them has the best code, because actually we have originated these routes. Okay, so to verify this, let's go over to router 2 and see what kind of information it has received from router 1. And as we can see that we have networks being received, okay, from autonomous system 13, okay. Some of them has the R code, okay, which means that we have or actually these prefixes failed to appear in the routing table using information from BGP, probably for example because of the lower administrative distance, okay, of other sources. So to verify the receipt of the information, I'm gonna show the routing table, and as you can see I have B codes BGP, for example the network 192.168.13, which is the network between router 1 and 3, also the 192.168.10/24, which is the LAN network right here, okay. All these networks have been learned using BGP at router 2, and let's verify the reachability. I'm gonna ping 192.168.11, which is an IP address in this local network. Actually, this is the IP address of the loopback interface right here. This is like loopback 1 or something, okay, and this is the IP address of the loopback interface I'm pinging over to. So what I really want you guys to see is how redistributed information would look like in the BGP database. You will see a question mark at the end, or actually at the origin code. Okay, we agreed that the question mark incomplete means that these routes have been injected into BGP using redistribution, and this is exactly what happened. Okay, to disable redistribution, we're gonna go back to router 1 and we're gonna remove the redistribute connected command using the no form of this command. This will disable redistribution, and to verify this I'm gonna go over or back actually to router 2 and view its BGP database, and yes, we do not have any routes being redistributed because actually we have disabled redistribution on router 1. So now we've seen that we could be injecting routes using the network command. We could be doing redistribution from the IGP. We could be redistributing routes from REP, OSPF, EIGRP, wherever, into BGP to get prefixes into the BGP database and send them over to other routers. To verify our configuration, we've seen that to view the database, okay, we could be using the show IP BGP command. Show IP BGP summary shows the summary for neighbors. Show IP BGP neighbors shows a lot of information, okay, about the neighbors. Show IP BGP neighbors and then the IP address of the neighbor shows a lot of information but about certain neighbor. Show IP route shows the whole routing table. Show IP route, then specifying BGP as a source, it will only display routes managed to enter the routing table using BGP. Show IP route and then specify certain IP address, it shows what prefix or actually what entry will be used to reach this IP address right here. We could be showing network as well. We could actually be showing multiple prefixes using the longer prefixes. Here we specified 255, 255, 224, which means /19, right? So we are specifying that we need to show anything that matches this IP address right here, /19 or more. More like /20, 21, 22, and so on. If you want to clear BGP neighborship, you could be clearing all neighbors using the clear IP BGP asterisk, means all. Clear IP BGP and then specifying an autonomous system clears only neighbors from this autonomous system, or you could be clearing certain neighbor specifying its IP address. The pipe right here means or. You could be clearing all